Now see the first question based on theorem, section formula for internal division, section formula for external division and centroid formula. So see the first question. Find the position vector of R which divides the line joining the point P and Q. That means if line segment PQ is given, whose position vectors are 2i minus j plus 3k and minus 5i plus 2j minus 5k in the ratio 3:2. So we have to find the position vector of point R which divides this line segment PQ in the ratio 3:2. So first we have to find the position vector of point R when this R divides this line segment PQ internally. So first we write position vectors of PQR. So we have to write here, let P bar, Q bar, R bar be the position vector of PQR respectively. So first we write position vector of point P which is given. So P bar equals to position vector of point P is given 2i minus j plus 3k. Position vector of Q is given which is minus 5i plus 2j minus 5k. Now we have to find the position vector of point R when that point R divides segment PQ internally. So we know the formula. If point R divides joining the point AB whose position vectors are R bar, A bar, B bar internally in the ratio m:n, then we write this R bar equals to m into B bar plus n into A bar upon m plus n. Now here instead of point AB, point PQ are given. Instead of ratio mn, a ratio is given which is 3:2. So we write here for given problem R bar is equals to in place of m we have to write 3. In place of B we have point Q. Position vector of point Q is this. So we write here minus 5i plus 2j minus 5k plus in place of m value is 2. So we write here 2 into, substitute the value of in place of A bar as P bar. So we write here 2i minus j plus 3k upon m plus n. So in place of m we write 3 plus 2. Now multiply by 3 to each term of first bracket and multiply by 2 to each term of second bracket. So we write here 3 5 is 15. So minus 15i plus 6j minus 15k multiply by 2 we get 4i minus 2j plus 6k upon 5. So add the like terms, minus 15i plus 4i which is equals to minus 11i, 6j minus 2j which is plus 4j, minus 15k plus 6k which is minus 9k upon 5. So this is position vector. You can separate the base, minus 11 by 5i plus 4 by 5j minus 9 by 5k. So this is position vector of point R. We can write its coordinate as R of minus 11 by 5, 4 by 5 and minus 9 by 5. So in this way we can find the coordinate of point R or position vector of R when that point divide this segment PQ internally. Now see, for external division. So if this point R divides this segment PQ externally in the ratio 3:2, so we have to use section formula for external division. So first we have to write, let P bar, Q bar, R bar be the position vector of P, Q, R respectively, and position vector of P is given, position vector of Q is given, and we have to find the position vector of point R which divides that line segment PQ externally. So we write here, if R divides the line joining the point AB whose position vectors are R bar, A bar, B bar, and that point R divides this segment AB externally in the ratio m:1, then we write position vector of R as mB bar minus NA bar upon m minus n. This is section formula for external division. So in place of in place of AB, we use point as PQ. So we write here, in place of value m, ratio is 3:2. So we write m as 3, n as 2, and B bar and A bar as Q bar and P bar. Or you can write here 3 into Q bar minus 2 into P bar upon 3 minus 2. In this way also we write, this is for only to compare with given theorem. So substitute the value of vector Q, substitute the value of vector P as we replace in first internal division also. So calculate this, we get, after multiplying by 3, we get minus 59 plus 6j minus 15k. Now multiply by minus 2, we get minus 4i minus minus plus 2j plus minus minus 6k upon 3 minus 2 is 1. So we add the like terms, minus 59 minus 4i which is minus 99, 6j plus 2j which is 8j, minus 15k minus 6k which is minus 21k divided by 1. So we write the coordinate of point P as 19, 8 minus 21. So in this way, when point R divide this segment PQ externally in the ratio 3:2, then the position vector of point R is calculated by using the section formula for external division, and coordinate we get minus 19, 8 minus 21. If question asks for position vector only, then we have to write R bar equals to minus 99 plus 8j minus 21k. Now see question second from exercise 5.2. Find the position vector of midpoint M joining the points L of 7, minus 6, 12 and N of 5, 4, minus 2. So we see the theorem for section formula for internal division, and from that we also see midpoint formula. So if R is the midpoint of seg AB and R bar, A bar, B bar be the position vector of R, A, B respectively, then R bar is equals to A bar plus B bar upon 2. This is called midpoint formula. So we have to write the position vector of point L, position vector of point N, and we have to find the position vector of this midpoint M. So in solution we write its position vector first. Let m of m bar and l of l bar, n of n bar be the position vector, and here coordinate of point L is given, so we write its position vector as L bar is equals to 7i minus 6j plus 12k, and position vector of N bar, because coordinate of point N is given, so we write N bar is equals to 5i plus 4j minus 2k. Now we have to find the position vector of M. So using midpoint formula, we can find position vector of midpoint, that is M bar is equals to, we write here L bar plus N bar upon 2. So substitute the value of L as 7i minus 6j plus 12k plus value of N bar, which is 5i plus 4j minus 2k upon 2. Now add the like terms, because here before the bracket sign is positive, so we can directly remove the bracket. 7i plus 5i minus 6j plus 4j plus 12k plus minus 2k upon 2. Now 7i plus 5i, we get here 12i minus 6j plus 4j, which is minus 2j, 12k minus 2k, which is plus 10k upon 2. So divide each term by 2, we get here 6i minus j plus 5k. So from this we can write the coordinate of midpoint M as 6 minus 1 5. So by using the midpoint formula, we can find the coordinate of that midpoint. Now see the next question. Question 3. If the points A of 3 0 P, B of minus 1 Q3 and C of minus 3 3 0 are the collinear, then find number 1 the ratio in which the point C divides the line segment AB, and second the value of P and Q. So we have to find the ratio in which this point C divides segment AB, but it is not given either that point C divides it internally or externally. So we consider here that point C divides this seg AB in the ratio lambda is to 1. So when we get lambda equals to positive, that means that point C lies between AB. If we get lambda equals to negative, that means that point C divides this seg AB externally in the ratio lambda is to 1. Then we get the ratio negative. When it's divided internally, then we get the ratio positive. That means the value of lambda decides either that point divide internally or externally. So we first consider the position vectors of point ABC. So write in solution, let A bar is equals to, so the coordinate of A is 3 0 P, so we write A bar equals to 3i plus 0j plus pk. Position vector of B, if we consider B bar equals to minus I plus qj plus 3k. And if position vector of C is C bar, then C bar equals to, we write here minus 3i plus 3j plus 0k. Now since points are collinear, suppose C divides seg AB in the ratio lambda is to 1. So we consider here that point C divides this sec AB in the ratio lambda is to 1. So we write here C bar is equals to lambda into B bar plus 1 into A bar upon lambda plus. So substitute the value of vector A, vector B and vector C here. So we substitute vector C as minus 3i plus 3j plus 0k equals to lambda into vector B bar. Vector B is minus I plus qj plus 3k plus 1 into vector A is 3i plus 0j plus pk upon lambda plus 1. So here we first multiply by lambda to each term of first bracket and removing the second bracket. So we write here this lambda we transfer to left hand side. So we write lambda plus 1 into minus 3i plus 3j plus 0k is equals to. So multiply by lambda we get minus lambda I plus lambda qj plus 3 lambda k plus remove this bracket because we are multiplying by 1. So 3i plus 0j plus pk. Now see the like terms I cap. So we take I cap common. So we write here minus lambda plus 3 into I cap plus, see the coefficient of j. So we write here lambda q plus 0. So we write only lambda q j cap plus, see the coefficient of k. So we write 3 lambda plus p plus k cap. Now if we observe, we can equate both sides. So before equating we multiply by lambda to each term. In LHS we write minus 3 into lambda plus 1 I cap, then plus 3 into lambda plus 1 j cap plus here 0 into lambda plus 1 means 0. So we write only 0 k cap. So by equality of vectors we equate the coefficient of ijk. So we equate this minus lambda plus 3 equals to minus 3 into lambda plus 1. So solve this first. So multiply by minus 3 lambda, minus 3 in left hand side, minus lambda plus 3. So after transferring this plus 3 to right hand side we get minus 3 and this minus 3 lambda to left hand side we write as plus 3 lambda minus lambda. So we get here 2 lambda is equals to minus 6. So lambda is equals to minus 3. So for equating the coefficient of vector, unit vector I, we get value of lambda. So we denote this as equation number 1. Now see coefficient of j. Coefficient of j is here lambda q. So lambda q is equals to, here coefficient of j is 3 into lambda plus 1. So we can substitute the value of lambda here. So we denote this as equation number 2 and we put lambda is equals to minus 3 from equation 1. So after substituting lambda equals to minus 3 in equation 2 we get minus 3q is equals to 3 into, here again we replace this lambda by minus 3 plus 1. So we get here minus 3q is equals to, here minus 3 plus 1 which is minus 2 into 3 which is minus 6. So we get here q is equals to plus 2. Now see the last term, here 3 lambda plus q we equate with 0. So from this we can write here 3 lambda plus P is equal to 0. So we denote this as equation number 3rd. So substitute the value of lambda equals to -3 in equation 3. So put lambda is equal to -3. Therefore 3 into -3 plus P equals to 0. That means -9 plus P equals to 0. That means P is equal to 9. So in this way we can find the value of PQ. Now we have to solve the first question. In first question we have to find the ratio. So in this way we calculate all the values, value of lambda, value of P, value of Q. Now we have to write the answer. So in first question we have to find the ratio in which the point C divides sec AB. Here we get lambda equals to -3 and we consider ratio as lambda is to 1. So we get here ratio -3 is to 1. So this from this value we can say that point C divides sec AB externally because value of lambda is -3. Therefore C divides sec AB externally in the ratio 3:1. We use here word externally, so we write here ratio 3:1. Then second we have to find the value of P and Q. So we get value of P is 9 and value of Q is 2. So in this way we can write the answer, or you can write the answer for first sub question 1 and then you can find the value of PQ. So in this way you can write the answer for question number 3. So the next question we will see in next part.